Hello, this is Mrs. Scarpel, and this video is going to review the main ideas of Lesson 1 from Unit 1. In this particular lesson, we are looking at a linear relationship and its inverse. And in the lesson, we have Carlos and Clarita. They are siblings who have a pet boarding service, and they were shopping around for different suppliers for dog food, and we're only going to look at one of the suppliers from the lesson as a review here. So the company we're looking at sells 8 pounds of the Brutus Bites for $6 plus a flat $5 shipping charge for each order. And the company advertises that they will sell any amount of food at the same price per pound. So with Carlos, we are going to complete a table, and then we are also going to graph the information and write a function for it. So keep in mind it is, let me double check here, $6 per pound of food. Yep, $6 per 8 pounds plus a $5 shipping charge. So what that means is if they don't sell, or if someone isn't buying any, they would be shipped an empty box for $5. But if they decide that they want to purchase the 8 pounds, it would be $6 plus the $5 for a total of $11. So if we double the pounds, 16, we have to double the price. So that's going to be $12 plus the $5 shipping for a total of $17. And then if we add another 8 pounds, that means we add another $6. So that's $18 plus $5 for a total of $23. Now we should be able to see from this table what our rate of change would be like. So we are adding 8 every time. To our input, and when we do that, our output increases by 6 each time. Now, as you can see, my graph doesn't allow me to plot points beyond the 8 pounds, but for a line, I only need to graph 2 points and then draw the line through them. So for this particular situation, we said we could order an empty box for $5, and 8 pounds would be $11, but notice how I don't have that option to graph that on here. So let's take a look at this. 8 pounds, $6. Both of them are even numbers. And I could describe my rate of change or my slope as being a rise of 6 for every increase of 8. Well, that simplifies to 3 over 4. So from 5, if I go up 3 and to the right 4, I would have another point of my line. And if we think about that, if I do 4 pounds, I should have half the cost, so that should be an increase of 3 for a total of $8. And I'm going to draw my line through there. So this is my line. Now let's write our function. We have a y-intercept of 5, and we have a slope of 3/4. So our function can be written in the slope-intercept form, y equals mx plus b. So as a reminder, slope-intercept form is y equals mx plus b. But we're going to use p for pound and d for dollars. So d, which is our y value, our output value, equals our starting value of 5, or to stay with the mx plus b, let me change that. We found that our slope reduces to 3/4, so d equals 3/4 p, because pounds is our input, our x-axis, plus our y-intercept of 5. And that's our equation for Carlos's approach, where he looked at, well, if I order a certain number of pounds, then I will pay this much. Now his sister Clarita actually looked at it a different way from that, and she looked at it as, for so many dollars I can get so many pounds. Well, that's essentially the reverse or the inverse way of Carlos's view. So we would switch our columns. So the 8, which had been, let's just double check, 11, and the 16 pounds had been 17, and the 24 pounds had been 23. So $5, 0 pounds. $11 is on the very end here, 8 pounds. I can graph my line. Now you notice Clarita doesn't end up with a y-intercept, she actually has an x-intercept. And if we check the slope from the graph, we would be going up 8 and to the right 6. So if we look at that slope, we have m equals a rise of 8 over a run of 6. Now we can simplify that. Both of these are divisible or can be divided by 2. So this becomes 4 over 3. So this is what we call the reciprocal of our previous slope. When you can flip the fraction upside down, you have the reciprocal. So here we had 4/3. Carlos had 3/4. And we can check on the graph, if we go up 4 and to the right 3, we should have a point on our line. Now, because we don't have the y-intercept, we cannot use the slope-intercept form for writing the equation of the line, so we need to use what's called the point-slope form. And that form looks like this. Y equals m, so slope, just like it was for the slope-intercept form, times x minus x1, this is a change from before, plus y1. So there's no b in this one. The x1, y1, that's our point from our line. M is still the slope. So we have our slope 4/3. We could use any of these pairs to write our equation. I'm going to go ahead and use the second pair. It really doesn't matter which pair you use. You can write an equation using any of them. y equals, our slope is 4/3, times x minus, this is always a minus here. The only time we would write a plus is if our x value happened to be negative, which it isn't in this case. So x minus 11 plus 8. And I'm not going to distribute this because it's just going to give us a bunch of fractions, and it's not going to look real pretty when we simplify it. And because this is a form for the equation of a line, we can keep it in this form. Now, we noticed that Clarita has an x-intercept while Carlos had a y-intercept. We also have our tables are switched. The inputs and the outputs reverse, they switch columns, and our slopes are reciprocals. Those are all things that are in common for linear functions and their inverses. So our takeaways here are that the inputs and outputs in the tables are reversed. X and Y are reversed. The slopes are reciprocals, meaning you flip the slope of your function upside down and you have the slope of your inverse. The graphs are reflections over the line y equals x. Now, that line y equals x, if you have a graph, let me just draw an axis here. If you have your x and y axis, the line y equals x is a diagonal line where your x value is the same as your y value. So that line y equals x looks something like this. Oops, that's a little too slanted. Let's erase that. I want it to be more right in between the center. So more like this as a sketch. So the lines, if we were to overlay Carlos and Clarita on the same graph, Clarita would have started on the x-axis and followed a slope of 4/3, and Carlos would have started at 5 and followed a slope of 3/4, and they would have eventually met somewhere on this line y equals x. And that concludes the review of a linear function and its inverse.